In this video, we're going to do two more truth tables as examples. So, first question, draw the truth table for not P or not Q, arrow not P. So I'll do it the long way. We'll do each row individually, so we'll do a column for each connective. Okay, so first one is P and Q. So we have P can be 1, 1, 0, 0. Q will be 1, 0, 1, 0. And I'll make a nice long line across the top. Okay, so first one we have is we have a not Q and a not P in there. So we'll do a line for not P. We'll do a column for not Q. So this just takes the opposite. So if P is a 1, not P is a 0. And if P is a 0, not P is a 1. For not Q, if Q is a 1, then not Q is a 0. If Q is a 0, then not Q is a 1. Okay, so our first one we're going to do here is P or not Q. So we're going to mix these two together. So P or not Q. Okay, so this is true if either P is true or not Q is true. So here we have P is a 1 in the first one. In the second line, P is a 1. In the third line, P is a 0 and not Q is a 0. So our result is a 0. And in the fourth row, P is 0, but not Q is a 1, therefore the disjunction is a 1. So P or not Q is going to be 1, 1, 0, 1. Then we're going to take the negation of that, so we're going to have not P or not Q. So we just take the negation, so instead of 1, 1, 0, 1, we'll have 0, 0, 1, 0. And then we'll put it all together. So our last line is going to be not P or not Q, arrow not P. So we're taking a look at these two columns here. So again, this is only false when not P or not Q is true and not P is false. So in our first row, not P or not Q is false, therefore the conditional is true. The second line, it's also false, so it's automatically true. In the fourth line, it's false, so the conditional is true. And in the third line, we have a 1, and that's conditional pointing to another 1, therefore it is true. So this is a tautology, not P or not Q, arrow not P. Now we can see this because this is the same thing as saying not P and Q, arrow not P, which is just this, conjunction elimination, or sometimes just called elimination. There's a few other words for it. Simplification is another word for it. So it's basically saying we have this conjunction of two, so we can take one of them on their own, and that's what you get out of it. So that is a tautology. In the second one, we want to show that P and P arrow Q produces Q. Okay, so do the same thing as before. We do P and Q columns. So we have 1, 1, 0, 0, 1, 0, 1, 0. The first thing we see here is we have a P arrow Q. So let's do that one. P arrow Q is only false when P is true and Q is false. So we get a 1, 0, 1, 1 here. Now we have P and P arrow Q. So let's do this one next. P and P arrow Q. So this is true when both P and P arrow Q are true. So it is going to be true in the first column, or true in the first row, and false in the remaining rows. Okay. And then this is all arrow Q. So we have P and P arrow Q, arrow Q. So let's take a look at this. Our first line, we have 1 pointing to 1. So this is going to be true. And in the second, third, and fourth rows, these are all false. So the conditional is true, because we remember that if we have P arrow Q. If the antecedent is false, then the condition is true regardless of whether Q is true or false. So those were the two examples. If you have any questions about these, please leave them in the comments below. If you have any other questions, leave those there as well, and I will respond to them as quickly as I can.